Today on Chinchilla Squeaks, I am joined by Shahar from Groundcover. How are you doing? Where are you joining me from, Shahar?
Hey, Chris, thanks for having me. I'm actually joining you from hot yet beautiful Tel Aviv in Israel.
Yep. I seem to be interviewing quite a lot of people from Tel Aviv this week. So it means we can actually do the interview at a good time of day for both of us, which is nice as well. So.
Exactly.
And we're here to talk about ground cover. What is ground cover? What are you bringing to whatever space you're in?
So groundcover is basically reinventing application performance monitoring for Kubernetes environments. The idea behind what we're doing at groundcover is trying to redefine the way an APM or an application performance monitoring solution would actually operate and behave in the way that it works by being more scalable or more data efficient and kind of more fit to modern architectures like, microservices architectures today, which are really API driven and high throughput and stuff like that. And we put that together with, an already well-known technology, which is called eBPF, which is really revolutionary in a way that eventually it allows us to access really deep observability from infrastructure all the way to application with no R&D efforts in between, with no code changes and nothing that can eventually cause a lot of friction during the integration. So putting those together is kind of what we're trying to do. And the vision behind what we're trying to do is make observability as effortless as possible for teams so they can enjoy it without working too hard for it, and scalable. So as they grow and as their team grows and the company and their customer base grows, the observability stack grows proportionally with them and, doesn't hold them back, basically.
So there's two distinct parts I'd like to dig into there. When you let's keep aside eBPF for now. I have covered it before on the show, but we'll do a quick recap of that in a minute. Let's have a look at the other side. Observability is a big space. eBPF is on one side. You have the old school, traditional APM on another side, and you have a lot of things in the middle as well. So how are you doing that part of things to begin with?
So I think basically when we look at, the pain points in kind of the world of application monitoring, application monitoring has been here for a while. Everyone knows how to, cite the three pillars, and there's no disagreements about, logs, metric traces being an important part of troubleshooting and performance monitoring, stuff like that. So we don't have to educate developers and us as developers. We know that for a while. The thing is that these solutions have been here for practically almost a decade, the basic solutions behind that. And they kind of drag on two problems into the space of application monitoring, which I think are not addressed so far in a proper way. One is complexity, which I think kind of relates to what you said about eBPF. Most of deep application monitoring is based on SDKs. So, you have to integrate an SDK into your code. Once the company is small and everything is homogeneous, it's all good. You can just run freely. But we've been meeting a lot of companies, and just recently we met a fintech company who has been integrating a solution like Datadog for over 4 months, and they're still in the midst of this process. So I think it's not weird to hear teams talking about quarters anymore, we're integrating Q3 Datadog into our stack, because it's more than just the complexity of integrating an SDK. Once you have to change code, you have to coordinate between a lot of different teams in a big company. So that's one part of the equation. And I think what happens there is that this complexity is just, it translates into R&D effort, but that's not the problem. The problem is that complexity and integration causes poor coverage, basically. Because if it's hard to integrate, you're gonna have to skip on some parts. For example, you're not gonna touch that legacy code that you don't want to touch anyway. But if it's complex to integrate an SDK there, no one's gonna do it. So we see teams are left with a lot of blind spots in their production due to the complexity of this integration and a long time to value, basically, until they get the value. So this is one part. It's kind of related to the eBPF and the ease of integration through something which is not an SDK, for something that doesn't require any code changes. But I think the other part is kind of more what you were looking for in that sense, and is the fact these solutions don't scale well. I think part of the reason for that is that solutions like Datadog, New Relic, and these great platforms basically were built over a decade ago when the market was mostly based around monolith architectures. Customer interactions were not as high in throughput like today, and they went for a centralized approach, which was really it made sense back then. I mean, send all the data back to Datadog or whatever, or the vendor of the observability you work with. They will crunch all the data there, create the insights, and let you investigate and query the data that you want. But the thing is that as architectures are becoming more and more API driven, and throughputs are rising, and microservices become more and more fragmented into different business units, eventually you just have to collect too much data to get this job done. And any interaction from a customer can create 10x or 20x interaction inside your cluster just from communicating between microservices and DBs and caches or whatever is happening there. So it creates also pricing models which are unpredictable, kind of scary. What's going to happen next month if the volume of my customers just suddenly peaks? And we see a lot of companies paying way over $1 million per year for these solutions. And actually, the kind of standard in the industry is talking about 10 to 15% of cloud costs being delivered to observability vendors, which I think we all agree is high and kind of exponentially grows with your stack, which is not that great. So this is the problem we're trying to address, because eventually cost causes a terrible trade-off where developers are put in a junction where they have to kind of reduce visibility to save costs or manage budgets responsibly. We see that all the time. I've been there myself, like firsthand. You reduce the granularity of that metric or that log level, or you sample these traces more hardly because you say I can't expect or predict what's going to happen in my build next month. So groundcover is heavily based on a completely different architecture around how we sample data, how we transform raw data into actual insights on the fly without ever, taking it out of the node or storing it anywhere. So data is much more efficient, much more scalable, and basically we also focus it to what we think you should care about once you kind of troubleshoot production.
So the tagline, the very big tagline on your website is mostly focusing on eBPF. I have covered it before. I spoke with Cilium, but I don't assume everyone listens to or watches everything. So it's a very hot technology, although again, based on not anything particularly new. But let's have a very brief summary from your perspective of what it is and why it's useful in this context.
Yeah, so eBPF is, I think, like all great technologies, it's not new in any sense. It takes time to build something great, I guess. So eBPF started from BPF, from the Berkeley packet filter. It was introduced in 1993, so it's almost like 30 years ago. But I think it was the first major leap in like what you can do inside the Linux kernel in a sense that people didn't expect before. When it introduced kind of a programmable virtual machine basically inside the kernel so that you can use to control and filter traffic. That was the purpose back then. I think it was kind of premature to what the data volumes and kind of the architectures that were used back then, in a sense that it was still kind of premature to the common developer or tech team of what they can harness it back then. But in 2014, just at the year that Kubernetes was released, funny enough, eBPF was released, which is the extension of BPF to actual tools that can allow you to deploy programs, like actual business logic that you can run inside the kernel. And that was a major jump in like what you can do, like the versatility of stuff you can run inside the kernel. The last couple of years were a total explosion in that. Recent kernel versions, which are highly adopted by Kubernetes vendors like EKS and GKE and stuff like that, contain a lot more flexibility, a lot more features. So developers can actually write code to the kernel that does a lot of interesting stuff. And for us, or from an observability perspective, it brings two important things to the table. One is efficiency. You get access to kernel level resources, so you can run complex code really efficiently and really safely. So when you're trying to monitor like high throughput protocols like say Redis or Kafka, stuff that can happen in really high throughputs, that efficiency comes into play, and you're not consuming part of the application's resources, but you're running inside the kernel in a much more efficient way. And the other great advantage, I think, is And the other great advantage, I think, is that from the kernel you can observe all of the user space, basically. So if you were a user space program, you wouldn't be able to kind of dig deep into other processes you're running next to. And that's why you had to integrate yourself into the code and do stuff that eventually kind of puts the developer in the loop. So, yeah.
And is eBPF, without going into too much trade secret, is eBPF what kind of reduces the cost and the overhead in your case?
So actually, no. I think that's part of the kind of misconception about what eBPF can do for observability. I think we see a lot of cool stuff and cool projects from all over the world around eBPF in observability, which is great. We totally believe in that. But eBPF is just another way, another very strong, very powerful way to get access to deep observability data from infrastructure all the way to application. But it doesn't solve the problem that eventually you have to do something with all this data. I mean, it kind of even worsens the problem.
Yeah.
In a sense, it makes stuff worse because now I have access to every DNS request. What I'm going to do with that? So I think it just kind of highlights the issue that if you're going to collect new data with this like new powerful source, something else has to change in the way you kind of collect, store, and digest the data. It doesn't make sense anymore to send all that to someone who will store it for you and let it query there. And I think that's the reason that even big vendors like Datadog, which is clearly going into eBPF really strongly. We're not saying we own eBPF. eBPF is going to be a commodity in a couple of years. Hopefully we're going to help it get there. But that's the reason why they won't be able to pull something completely different off with eBPF, because eventually it's just more data flowing into your observability stack, and someone has to handle it.
Yep. Okay, on that, I think you have a little demo, so I'll bring in the screen for you, and I will attempt to describe anything that isn't immediately obvious for audio listeners.
Sure.
So, what are we
try to be as
at
descriptive
first?
as I can.
Yeah.
So basically, we're currently looking at the groundcover SaaS experience, our UI. Before just talking about that for a second, just talking about the installation. Clearly, the installation is where eBPF is kind of the strongest play in what we can do here. The installation is a simple Helm chart. Basically, we deploy a daemon set that kind of runs the eBPF program on each of the nodes inside the cluster. And on the other hand, in our own separate code with our own separate transparent resources, we actually run this aggregation that I was talking about, of eventually taking all the data, surfacing from eBPF, aggregating it, turning it to metrics, and eventually serving it as an APM grade kind of value. So what you see here is kind of the first prism into the data that we collect. This is like one cluster we're currently installed on this demo cluster. We can be installed on multiple clusters and eventually aggregate all the data into one place. And this is an auto discovery of all the services or workloads that are currently running inside the cluster. We actually detect how they operate it at runtime, and not just using Kubernetes API. So we can tell you who's healthy and who's not right now. So what you're currently seeing in this kind of weather of sunny and rainy visuals is that some of them are currently unhealthy. And for example, this front end, the tile you see here of the front end, this is the actual workload. It can be represented by, say, 15 pods on 3 different nodes. This logical unit is currently experiencing 3 different issues, and these are not Kubernetes health checks or something like that. This is out of the box issues that groundcover catches on the fly while detecting, for example, that this specific workload is communicating over gRPC and HTTP.
So this could be not even a Kubernetes issue. It could be an error coming from the application code, like that as well. Okay.
Totally. And clearly, all the things that we do are completely Kubernetes native, so you can filter by namespaces and try to look at different stuff like workload and protocols. We cover a lot of different protocols from gRPC to HTTP to Kafka to DNS to Redis, even stuff in the TCP layer that can be interesting for an infrastructure team. And we also can create interesting things like that, which eventually kind of merge together our distributed collection, which data can be collected distributively from very different nodes, and eventually putting all this together using the Kubernetes metadata into something which is like this logical flow map that you just see here. This is an actual current runtime dependency map between the different services. And you can see, different error rates happening on some of the edges, which can be HTTP, gRPC, or anything else that we eventually detect.
This is a little bit of an upgrade to that usual topology kind of overview, isn't it?
Yeah, I think the cool part here is also that, we only need to see one side of the conversation in a sense. So even if we're talking about cross-cluster communication or managed services, like managed Redis or RDS or anything outside of the cluster, which is totally common, we're going to see that interaction. We're going to monitor that error rate. We're going to monitor that latency because we catch it from the client side. And the granularity there is going to be from your Kubernetes perspective. You're going to know who's the client behind that, who's the entity behind that. So things are much more, logical to the stack of your Kubernetes and not some IP, flowing around communicating with the RDS, which you're not sure who it is. So this is one cool part of what we can do. The other part that the groundcover is trying to bring to the table is kind of an inbox approach into troubleshooting, if you want. Trying to put all the issues that we out of the box detect in the cluster in one place from very different domains. So this is just our demo, so you can see problems in gRPC, HTTP, Redis, Postgres happening currently in the cluster. We also detect Kubernetes events, so there could be a container restart, happening from any different container in the cluster that we will indicate and help you troubleshoot, or an out-of-memory crash or anything like that. And each of these issues eventually are aggregated, by our aggregation mechanism. So this, for example, is an HTTP request that gets 500 failure status code from front end inside the cluster, which is the HTTP server here. But this happened 38 times in the last 15 minutes. Clearly, we're going to try and aggregate it for you. And once you dig in, let's say, just look at this gRPC error. Once you dig in, what we do is we capture spans on the fly. So we create two different kind of inputs, which are really APM grade value in that sense. One is the golden matrix of, requests per second, error rates, and their distribution by status codes, and the latency of, say, P50 and P95 on that specific resource, that specific API. And we also capture different spans, so you can investigate good examples. So this is, an example of the good payload traveling between the client and the server, which this request eventually ended up with a correct response. But you can also take it to investigate, the bad response, which eventually the gRPC stack reported an unknown error. So you can see, okay, what in that payload eventually triggered that request. And that's part of the really interesting part that groundcover does. We don't capture all the spans inside the system. We sample high latency spans, erroneous spans, things that are interesting, while also capturing some of the common spans, so you can kind of investigate and compare. That's why the data efficiency stays so high.
How do you filter out what may not be useful? When you say common and erroneous, that kind of sounds to me like all of them. But
we separate it into two different parts. We manage budgets for sampling, which are managed by each edge component, each agent running in each node. We sample all the failures until some kind of budget that we determine. And we learn the distributions of latency, payload sizes, status code distributions, stuff like that inside the actual edge model. And so we can sample from different parts of the distribution. So say in latency, we will always sample, say, P95 or really fast requests, sample from the edges of the distribution, with intent, because we learn the distribution on the fly inside the edge component. And from general population of requests, we will sample randomly with a specific separate budget, so you can also see random stuff that we might have missed from our narrow perspective on the sampling mechanism that we run. The result is that you can sample a really, really high throughput API and eventually be positive that you're going to get the 1 out of a million requests that failed even if it's that rare, which is kind of a major leap in the way sampling is currently operating in APM solutions, and that's why you're sometimes missing out on what you care about, and mostly collecting 99% of irrelevant data that you have to pay for.
Yeah. Okay. Yeah.
We do the same thing for logs also, which is kind of cool. We collect 10 seconds worth of logs. We actually keep the logs inside a ring buffer inside each edge component that is running in each node. And once an event happens, we dump those 10 seconds worth of logs into storage. So you get kind of our kind of indexing on your logs in a sense, by us telling you these are probably the logs you're gonna want to query. Yeah. So we keep them really efficiency and really accessible. We're not saying logs are not important like all over the system, but it's kind of a smart indexing into the seconds before and after an event. Yeah. From the relevant pods that took place in the specific incident. Okay. Yeah. So this is one take, and like the final take of what we're doing is performance monitoring, like hardcore performance monitoring. Eventually, you want to see all the resources inside the cluster, so you can figure out which one is a bottleneck, which one is causing you trouble. So we present the different protocols inside the system. We do it even for Kafka, Redis, Postgres. So you can even go, say, to Postgres and see all the queries running from all the clients inside your servers, inside your cluster, into external RDS services. And you can see which client inside your cluster from a Kubernetes entity perspective is using RDS the most, causing that much error, is experiencing, say, a peak in latency for some reason. And then you can investigate the specific queries that got him there. So it's really interesting to see it from perspectives of protocols like, say, Redis, where you can see all Redis commands and their kind of golden signals, and very common in things like gRPC and HTTP, where you actually get a lot of different examples of APIs running through your system. You can figure out who's communicated to who and at what metrics that are relevant for performance.
And is what you support here limited to certain resources at the moment, or is it just happens to be these are the examples in the example application you have here?
So it's completely not limited in a sense that we're almost entirely language agnostic. What we do support are specific protocols. So, for example, we're not supporting RabbitMQ yet. Okay. This is on our roadmap, but we do support Kafka, Redis, gRPC, HTTP, a lot of different, very common protocols that are run in most production environments. So our coverage slowly grows into newer protocols, but from a coverage perspective, in most cases, we don't care if it's Python running on top, Java running on top, if it's SSL encrypted or not. We know how to bypass and support all the different mechanisms around these APIs and DB queries and stuff like that. Again, assuming that this is a protocol that we support.
Yep. Okay. Cool. Anything else you want to show here, or shall I drop it out?
Just one like final thought on that, which I think is interesting for a lot of users out there. I mean, clearly Grafana Prometheus stack is a really common and widespread stack in observability, and a lot of users use it for infrastructure monitoring and different stuff like that, and also monitoring high throughput or DB related services like monitoring their Redis or Kafka broker performances and stuff like that. So we see it happening with a lot of teams. What's cool with groundcover is that the data is accessible as a Prometheus data source. All the metrics that you see here are accessible as a Prometheus data source. So
exported, you mean?
Yeah, I mean, you can actually add us as a data source, as a Prometheus data source. We're not actually running Prometheus because it wouldn't
for sure. It's a remote
hold the granularity.
Read or whatever they call it,
Yeah, so you can just, build dashboards from a lot of metrics that we create out of the box. We work with customers to create these dashboards, all documented, so people can also create their own. So it kind of opens up new use cases into, using the data that your observability stack is collecting, and not just sticking to our UI, which we think is great, but you probably have your own thoughts on how to troubleshoot with it.
Your UI is interesting. I like you're kind of going for this slightly more light-hearted a look and feel to a lot of observability platforms. And
Yeah,
I don't
yeah.
honestly know how some people will feel about that. I'm not sure, but it does certainly look
We know
different.
how we feel about it. I mean, there's sometimes you get lost inside these, huge dark blue platforms with
Yeah,
all these million tabs. There's also something we're trying to say there from a product
yeah,
statement, but that's us, and that's what we believe in.
yeah. Cool. All right. Take that out. Let's just go through a couple of more general questions to wrap up. I get the impression the company is relatively new. So what was the story there? Why did you decide to start? Who decided to start? And what problem were you facing that made you want to start the company?
So just to touch on our backgrounds, we're two co-founders.
Yeah.
We're good friends for over 10 years. Both of us kind of went through similar professional paths in our lives. So we've been engineers for over 15 years, each of us. And like most of this professional time was around like R&D leadership positions in different domains. I've specifically spent a lot of years in cybersecurity, like a lot of people from the Tel Aviv area you're talking to, and my last few years were around applied machine learning, most recently at Apple for a few years. And through all these kind of periods, both of us were on the user side of platforms like Datadog, New Relic, Grafana, Prometheus, and stuff like that. So monitoring was always something critical from our day to day and the way that we eventually managed our teams and our projects. So we always have been using these kind of platforms, so we knew where they work great and what are kind of their drawbacks and problems. And about a couple of years ago, we knew that we already had kind of a vision about how to collect data differently for production, troubleshooting, and monitoring, and what we want to do different there and make those solutions more scalable and more fit to the modern world. And it all kind of clicked about a year ago. We come from kind of the cyber way of thinking, so it's always been our interest to engage with low-level technologies and figure out how operating system works and technological frameworks operate and stuff like that. And we got familiarized with eBPF at some point where it was relatively new. Right now, it feels like it's a hot discussion, which is really cool. And that's where things kind of click. The vision of trying to do stuff differently in the 8PM domain, and this revolutionary technology that can make a lot of this happen from a friction kind of way for the R&D team. That's kind of where things clicked for us, and we knew that we had to build it into an integrated solution that would take both of these different ideas into one. And that's kind of where groundcover is positioned today in the world, trying to take these two approaches and kind of merge them into a solution that will create a different experience into application monitoring.
And so the eBPF aspect, like you mentioned, actually I can't remember who you mentioned out of the main players now, but I know, for example, New Relic bought out Pixie, who have also actually been on the show before they were acquired. And I think you also mentioned Datadog, did you, is now offering eBPF, or did I mishear you? Yeah. So, a couple of these larger vendors are starting to offer this now. So what do you think your point of difference is and is going to be to be noticed amongst those fairly well-established players?
Yeah, so first of all, regarding Pixie, I think they're a great team. They're pioneers in the field of eBPF. We've met them also here in Israel and also at their offices, and truly appreciate and love what they're doing. We actually work together. We will contribute code back to Pixie because we really believe in the community motion that they're creating. But I think Pixie would also acknowledge that there's a lot of difference, and it kind of relates to Datadog also in that sense. There's a lot of difference in what we're trying to build, like say the difference between groundcover and Pixie. Pixie did a great job at showing what a great data source eBPF can be. Exposing things that were before unheard of, from an application layer of, what eBPF can put on the table. But as I said before, and I think Datadog is heading kind of in the same path, they just made more data accessible, which is amazing. And they showed they kind of made the proof of concept of eBPF providing this data without you ever touching the code. But then we kind of feel it's back to square one of what do I do with all this data? Who's going to handle it? Who's going to pay for it? Who's going to store it?
Yeah.
And that's, you still need someone to do the aggregation for you and kind of focus you on what matters. So I think that's kind of the difference in the approach, even between us and Pixie, even though clearly from an eBPF perspective, we totally believe in what they do. And as I said before, I think Datadog, New Relic with Pixie and other vendors, eventually eBPF will hopefully be a commodity. I mean, clearly it's currently very far from the average developer, and we're trying to make it accessible. Yep. But holding it back from the community is not what's going to make a dent in the APM world. We believe it's mostly the other part of combining it with a completely different approach into how you aggregate the data.
Yeah. Okay, and you mentioned a couple of small things along the way, but what's on the roadmap for the next 6 months?
Yeah, so groundcover is actually launching really soon. I mean, we just closed another funding round, so we're going to be announcing it soon. And basically, we're already open to the world with a free tier that we really believe in. It's completely self-served, so everybody can try it out. Go to groundcover.com and install, and we totally want this feedback from developers, from teams, actually working in real Kubernetes environments. And we have great plans to expand the product to create a truly Kubernetes native APM that can kind of bounce between the infrastructure that you care about and actual APM value that as you see in the demo. A lot of roadmap into expanding into new protocols and different stuff that we hear from customers all the time, and growing the team since we're currently in high growth year. That's basically our on our agenda.
Everything then is on the agenda.
Yeah, rule the world.
Cool. Shahar, thank you very much for your time, and thank you for joining me today.
Thank you, Chris. Thank you for having me.